Let's take a look at an example of finding a volume of a solid of revolution where we wish to revolve our curve about the x-axis. You'll notice that we had in a separate video an explanation of our formula for the volume of a solid of revolution. That was the integral from a to b of pi times the radius squared. And we'll take a look at how that plays out in the following example, where we have a solid that is generated by revolving the curve y equal 4 minus x squared about the x-axis, where we are between x equals 0 and x equals 2. And we want to find the volume of that solid. I've taken the liberty of going ahead and first drawing in the curve y equal 4 minus x squared between 0 and 2. It's fairly easy to do by plotting points. You have the point 0, 4, 1, 3, and 2, 0 on your curve, and of course it is a piece of a parabola. But that's not the only part of the diagram we need. One of the keys to working these problems are to get a diagram that gives you a good picture not just of the curve, but also of the entire object and where you are rotating around, as well as what the radius would have to be. So our first step is that we are revolving about the x-axis. So I'll go ahead and draw a little curly thing here with an arrow showing that we are revolving about the x-axis. So about whatever axis we're going to revolve, you can put such a circular arrow to help you know where the center of the revolution takes place. Now, the next thing we should do is to reflect our curve across that axis of rotation. We do that so that we can see where the rest of the curve lies as it is rotated around to the other side. So instead of 4 units above, the reflection would go to 4 units below at 0. When x is 1, instead of 3 units above, it would be 3 units below. And then any point that is on your axis of rotation would, of course, stay there. So we would have that curve as its reflection. And now let's think of actually rotating where it would come up above the page, back to the second curve we've drawn, and then below the page. So how are you going to draw that? One way to do that would be to draw typical places where you are doing your rotation. And then you see this looks something like some kind of a bowl, not quite a bowl because it has a point down here at the bottom. So maybe turn your head to the right and it looks like some kind of a pointy helmet that someone might wear. But again, that's the idea here of what this solid would look like. Alright, so we have drawn a curly arrow at the axis of rotation. We have reflected our curve across that axis and then drawn our picture. But the last thing we need to draw in that will be helpful is your typical radius. And that's because the radius, of course, is part of your formula. So here's what we need to do. We need to pick some point on the curve, such as this one. And then we draw a line from that point on the curve perpendicularly to the axis of rotation. So here's my axis of rotation down there. So I've drawn a perpendicular line segment from my curve to that axis of rotation. That is again our typical radius. Now why is that helpful? Because here it helps us see that the radius is a y coordinate, it is a vertical distance, and it is the distance from the x-axis up to the curve. Well, that's exactly what's given by our formula for the curve y equal 4 minus x squared. So that means that our volume is going to be the integral of pi times the radius, and here I've said my radius is 4 minus x squared, then squared. Remember, it's the radius squared, so my radius was 4 minus x squared, so it's that quantity squared. Integrating with respect to x is according to our formula. And now what about a and b? A and b are the 0 and 2 because our solid then appears along the x-axis between 0 and 2. So now all we have to do to finish is integrate that function, and we will be done. So that's integral from 0 to 2 of pi times, let me go ahead and square the 4 minus x squared. That would be 16 minus 8x squared plus x to the 4th. So then when we find an antiderivative, that's pi times 16x minus 8/3 x cubed plus x to the 5th over 5 from 0 to 2. Do your arithmetic and you get 256 over 15 pi, and our units are cubic units because this is volume. Now, of course, if you would rather approximate on the calculator rather than do your exact arithmetic, you would wind up with about 53.6 cubic units. Alright, so again, the idea here is that we will always integrate pi times the square of the radius, and you have to figure out what that radius is and then go from there. And because we have something squared, it will often be a binomial, or maybe even 3 terms or something in there. So you do have to remember how to square a binomial correctly, that it's your a squared plus b squared plus your 2ab. So don't forget that middle term when you square the binomial. Alright, and that's all there is to finding the volume of a solid of revolution when you revolve about the x-axis.